Hello everyone and welcome to our video. Today I Diya Mathur, undergrad from JK Lakshmipat University,
And I am Mayuraj Singh.
are very excited to share that we have completed building a project for LLM class under the guidance of Professor Kshitiz Verma.
That's right. In this project, we built a GPT-1 language model entirely from scratch. We had like to take you through a journey from the initial idea to the final code and its capabilities.
Before diving into the project details, let's talk about LLM course at JK Lakshmipat University. Professor Verma has created an excellent curriculum that dives deep into large language models and their applications. His guidance throughout the course was invaluable.
Now, GPT-1 stands for Generative Pre-training Transformer 1. It's a powerful AI model that can generate human quality text. It works by analyzing a massive data set of text and learning the relationship between words. It allows it to predict the next word in the sequence and create coherent sentences, paragraphs, or even entire stories. Now let's jump into the code and see how things work. First, we import all the necessary libraries and set our system to make this GPT. After that, we define all the necessary parameters like batch size, contest length, training alterations, learning rate, and model architecture. These parameters significantly influence the model's training process, performance, and memory usage. We have built GPT on a very small scale due to lack of computation. That's why we have trained it on our own CPUs. Now let's just talk about our data. We took entire 7 volumes of Harry Potter as a text data for this. As you can see, these are all the 7 volumes of Harry Potter we accumulated. It combined around almost 1 lakh line of text. After that, we just did a vocabulary creation. That creates a dictionary mapping each unique characters in the text to a numerical index and vice versa. This efficient representation enables the model to understand and generate text using these indices. After that, we did encoding decoding. We created the encoding and decoding functions. These functions define how to create text strings into sequence of numerical indices and how to convert the model's numerical output into human readable text. They bridge the gap between human readable text and the model's internal numerical representations. After that, we did train test split. This split the prepared data into training and validation sets. The training set is used to train the model, and the validation set is used to monitor its performance during training and prevent overfitting. After that, you can see that data loading. This creates many batches of training or validation data. It randomly selects subsequences of text from the appropriate dataset and prepare them as input and target output tensors for the model. This facilitates efficient training by processing small chunks of data at a time.
After this, we have created a loss function. The loss function evaluates model's performance on both training and validation sets. It calculates the loss on these sets and helps us track the model's progress and identify potential issues during training. The code begins by defining several classes that are fundamental building blocks of transformer model. The first class, that is head, represents one head of self-attention. It calculates the attention scores, performs weighted aggregation of values, and uh, and a lot of things. Then the class is multi-head attention, which consists of multiple heads of self-attention which are running in parallelly. Then comes the feed-forward class, a simple linear layer followed by a non-linearity which is applied after self-attention in the transformer architecture. Next is the class block. The transformer block, which consists of layer of multi-self attention head and followed by a feed forward neutral network. Now, next up is the GPT language model, which encapsulates the entire architecture of language model. It initializes embeddings for token and positions. It stacks multiple transformer blocks together. It applies layer normalization after the transformer blocks, and it also defines final linear layer, which is LM head, that predicts the next token. Now, the initialization method, the model's parameters are initialized following the best practices uh, for transformer architecture. The forward pass method takes input indices and optional target indices. It computes the logits for the next token using transformer blocks and returns them. If targets are provided, it also computes the loss during cross entropy. The generated method the generated method generates new text given an initial context. It iteratively predicts the next token sample from the predicted probability distribution and appends the sample token to the context. The process continues for a specified numbers of tokens. The training loop. Finally, the code demonstrates initiates an optimizer. It iterates over a fixed number of iterations that is mentioned above, evaluating and saving the model periodically. In each iteration, it gets a batch of data, computes the loss, and performs back propagation, and then updates the model's parameter. After this, it took around 1 to 2 hours of this code to generate the text. And as you can see here, we have listed the output that it generated. It generated around 10 million parameters, and it took around 10,000 iteration with training loss and validation loss. With each iteration, the loss was decreasing and there was no overfitting. After the iteration completed, as you can see, this is the generated text. It doesn't look very good, but it could be good if we increase the number of parameters, and if we had a good computational GPU. um so that's all for the code.
Building a complex model like GPT-1 from scratch definitely wasn't easy. Here are some challenges we encountered. The computational resources. Training a large model required significant computing power. We had to optimize our code to leverage resources to complete the training process efficiently. Second, the fine-tuning the model, optimizing the model's internal parameters known as the hyperparameters to achieve the best possible performance involves a lot of experimentation and adjustment. Overcoming these challenges was a great learning experience. We gained a deeper understanding of transformers, language modeling techniques, and the entire machine learning development workflow.
Building GPT-1 model from scratch was a challenging but a rewarding project. We would like to thank Professor Verma for his guidance throughout this journey. We hope this video has given you a glimpse into the world of large language models and the exciting possibilities they offer. Thank you.
Thank you, everyone.